All right, today is our last section of the volumes using discs and washers. So just a refresher, if your axis of rotation is horizontal, meaning you're going to rotate about a horizontal line, then we were integrating with respect to x because our cross sections were perpendicular to the x-axis, therefore had thickness delta x. So if we are rotating about a horizontal line, we integrate with respect to x. All of our functions need to be of the form y equals f of x. If we had a vertical line of rotation, a vertical axis of rotation, we integrated with respect to y because the thickness of our cross sections were delta y. All of our functions needed to be of the form x equals f of y. So for our horizontal values, our horizontal axis of rotation, we also had our bounds being x values. Our vertical axis of rotation, our bounds were y values. Today we're going to be rotating about external lines, meaning a line that is not our x or y axis. So the radiuses are a little bit tricky, radii are a little bit trickier to find. And so drawing the picture for most people is very helpful, especially if you're not a very visual person. It can help you figure out where your radii go. Again, you might have discs, you might have washers, but your axis of rotation is going to be somewhere that is not the x or y axis. So we're going to find the volume of each solid obtained by rotating the region bounded by the given curves about the specified line. Okay. So here we've got let's just draw our pictures of what these are going to look like. Okay, so we've got y equals x squared. We've got the line y equals 4. And we're rotating about the line y equals 4. So we're rotating about a horizontal line. This means that we're going to need upper and lower bounds that are x values. Okay. Our discs or our washer should have a radius are in terms of f of x, okay? Or in other words, y equals, which is what we have, okay? So this is the region that we are rotating, okay? We're starting here and ending here in terms of our bounds, okay? And so when we rotate, what this thing is going to end up looking like is sort of like a pontoon or a football, okay? So we're going to end up with cross sections that are discs. So we should have a equals pi r squared. We don't have a big R, little r, just one. And the question is, well, what is the radius of each of these discs? So the radius would be this chunk here. And what is that radius? Okay. Well, this entire distance here is 4 because we're rotating around the line y equals 4, right? We were rotating here. Okay. But that's not the radius. The radius is only this chunk. So it's a little bit shorter than 4. And the question is by how much? Well, if I take a look at my picture, the chunk that's missing is this chunk here, which happens to be the height of my curve. Okay? So this height is the height of the curve. So r plus f of x gives me 4, which means that my radius is 4 minus my f of x, or 4 minus x squared. So my volume is going to be the integral from a to b, which we need to find, of pi times 4 minus x squared dx. So we need to find these two values. Well, if we're intersecting at 4, we have x squared equals 4 is our intersection, or x equals plus or minus 2. So negative 2 to 2 is where I'm integrating. So I'm going to take out my pi, go from negative 2 to 2, and I'm going to expand this. I'm going to get 16 minus 8x squared plus x to the 4th dx. which gives me pi 16x minus 8 over 3 x cubed plus 1 over 5 x to the fifth, evaluated from -2 to 2. The other thing we can do is we can notice that this is the same thing as saying 2 pi from 0 to 2 of 16 minus 8 x squared plus x to the fourth dx, since this area on the right is the same as this area on the left, meaning the volume of this chunk will be the same as the volume of this chunk. Okay. So remember that if you were continuous, this was one of our properties of integration. So this gives us 2 pi times 16x minus 8 over 3 x cubed plus 1 over 5 x to the fifth from 0 to 2. So I should get the same answer either way. Okay. Now, obviously, the one on the right-hand side might be a little easier because you're not having to subtract. You're subtracting 0. Okay, so I'm going to continue with that one. So I get 2 pi times 32 minus 8 times 8, 64 over 3. Okay, plus 32 over 5. If we make common denominators and figure all that out, we get 512 pi over 15. And you should get the same thing if you continue down with this one. That's it. All right, let's try another one. All right, we've got the line y equals x. And we have the line y equals root x. About x equals 2. So the first thing I would do is figure out where are these intersecting. Okay, so we have x equals root x, or 0 equals root x minus x, or 0 equals root x, 1 minus root x, or 0 or 1 equals x. So this is at 0, this is at 1, which means the line y equals 2, or sorry, x equals 2 is over here somewhere, and that's where we're rotating around. Okay. So if I picture this rotating, I've got this object here. I've got this external line here that I'm rotating around. And that means that this is going to end up mirroring itself on the other side. That's a bunch too big. Let me fix that. Draw a little bit more of my axis here. Like this. And so when we have a cross section, our cross sections are going to be perpendicular to the y-axis since we're doing a vertical axis of rotation. And if we're doing a vertical axis of rotation, we're going to be integrating with respect to y, and everything should be in terms of y. So when we're looking at our a and our b, we're starting at a lower bound, ending at an upper bound. And our upper bound here would also be 1, because if x is 1, y is 1 for both of these situations. So we're going to be integrating from 0 to 1. But in this case, we have a washer, so we need an inner radius and an outer radius. Okay. Our inner radius would be right here, inner radius little r, and we see that that extends from y equals x out to 1. Okay. Or sorry, out to 2. So if I think about my entire distance here is 2. My inner radius is this distance here, and this distance here is y equals x. So our inner radius is 2 minus y. We know we need it to be with respect to y, which is why we're doing minus y and not minus x. If we think about our outer radius is coming a little bit farther. Our outer radius is reaching this point right here. So our outer radius is this entire distance, and the leftover distance here that we didn't have is our other function, which is y equals root x. Okay. Or in other words, if y equals root x, y squared equals x. So this extra distance is, x equals y squared. So our outer radius r is 2 minus y squared. The reason we're using this left side and not the right side is because the left side is what we started with before we rotated it. So this is our original side, and that's where we're going to write our equations for our radius from. Okay. So that means our volume is the integral from 0 to 1. Right? Remember, if x is 0, y is 0. If x is 1 here, y is 1. Okay, we have pi times big R squared minus pi times little r squared with respect to y. As with before, we can take that pi out. We have 0 to 1. I'm going to expand both quadratics. I'll have 4 minus 2y squared plus y to the power 4th minus 4 minus 2y plus y squared. Hopefully we'll notice that these 4's cancel out. We'll end up with pi, the integral from 0 to 1. We end up with 2y. We end up with negative 3y squared plus y to the 4th. Someone went wrong somewhere. This should be a 4. Sorry, this should be 4y squared. And this should therefore be 5y squared down here, not 3. There we go. Sorry, I expanded that first quadratic incorrectly. Okay, so when I expand the first quadratic, I should have 4 minus 4y squared plus y to the power 4, which means when I combine my like terms, I end up with minus 5y squared. So then I can integrate, end up with y squared minus 5 over 3y cubed plus 1 over 5y to the 5th, evaluated from 0 to 1, gives us pi 1 minus 5 over 3 plus 1 over 5 minus 0, or pi 15 over 15 minus 25 over 15 plus 3 over 15. And I've just realized I forgot my 4 in the second set too. I'm so sorry. So if we go back up to this line here, I should have had a 4 in that middle one as well, which is going to make this a 4, which is going to make this a 2y squared, which means when I plug one in, I get 2, which makes this 30 over 15, which gives us 8 pi over 15. So go back up to this line here, change this to a 4, not a 2, which is going to change this to a 4, not a 2, which changes this to a 2, this to a 2, this makes it 30, and then we get our final answer. All right, let's try one more. Okay, a solid has its base as the region bounded by the lines x plus 2y equals 6, x equals 0, y equals 0, and the cross sections taken perpendicular to the x-axis are circles. Find the volume of the solid. Okay, so let's draw this thing. Okay, So we've got x equals 2y minus 6. I would choose to rearrange this in order to graph it. So I'd have 2y equals negative x plus 6, or y equals negative 1/2 x plus 3. Make this 3, 2, 1, 1, 2, 3, 4, 5, 6. Okay, and it's bounded by the line x equals 0, y equals 0, so we're looking at this triangle here. Okay, so this is, its base is this region, okay? And it's saying the cross sections taken perpendicular to the x-axis are circles. So in other words, we're not rotating this, we're picturing an already complete 3D object. And I'm going to draw my axes just sort of sideways so we can see what this would look like. So basically this is heading down towards here. And if we are cutting this object, we're seeing circles pop out. Okay? So it's not being rotated about the axis. This is already our 2D version of our 3D object that is a solid where this is the base. Okay? So we're seeing circles. If we take the cross sections perpendicular to the x-axis, we have these circles here. So in other words, it kind of looks like this. Okay? It's kind of like a cone where this is a right angle and this is slanting downwards. Okay? So if we think about it, it looks like a cone that kind of looks like this. Okay? And the question is, well, again, if we wanted to find the volume of this thing, we would be adding up all these circles, right? This is sideways though, so our circles are popping out like this. So we're not rotating it, it's already a solid. Okay? And if we wanted to find the volume of this solid, we would take the integral from 0 to 6 because we are perpendicular to the x-axis. So we're going to integrate with respect to x, and our bounds should be x values. Okay, so in this case, our a is 0, our b is 6 because that's where we're starting and ending. We would still have pi r squared, but in this case, the question is, well, what is our r? Well, r in this case is our distance from halfway between the x-axis and the function up to the edge of the function. Okay, so our entire distance here would be f of x. That's our diameter in this case. So our radius is 1/2 f of x. Or in other words, 1/2 of negative 1/2 x plus 3. Just get rid of those brackets that are in my way. All squared. Okay. And then we're integrating with respect to x. Now, you won't always get circles. It could be that they are equilateral triangles or squares or whatever other shape. In that case, then you need to think about how to find the area of that shape. So we're doing circles, which is why we're doing pi r squared. If we were doing the cross sections taken perpendicular to the x-axis were squares, well, the area of a square is the side squared. So we would have to figure out what the side length would be. If it was this same shape, then I would have squares coming out of this thing. And the side length of one square would be my f of x. Okay, so I would have f of x squared as my area. So I would integrate that. Okay, so just pay attention to what shape you're dealing with. Okay, you might be told that you have a triangle where the base is half of its height or something like that. So being able to picture what these things look like will vastly help you figure out what your side lengths are supposed to be and what your area is supposed to be. All right, so let's calculate this. So I'm going to take the pi out. We've got negative 1/2 x minus or plus 3 over 2 squared dx. This is going to give me pi 0 to 6. I'm going to have 1 over 4 x to the fourth plus 3 over 4 x and never mind, just a moment, this should be 1 over 4x squared. Okay, we distribute our 1/2 in. This gives us negative 1 over 4x plus 3 over 2 all squared. So this should give us 1 over 16 x squared plus minus 6 over 8. I'm sorry, x plus 9 over 4 dx. Now you can take a 1 over 4 out of all of this if you'd like. Make this pi over 4. And this becomes x squared over 4. This should be the same thing as 3 over 4. So minus 3x is 9 with respect to x. This gives us pi over 4, x cubed over 12 minus 3 over 2x plus 9x from 0 to 6, pi over 4, 6 cubed over 12 minus 18 over 2 plus 54 minus 0, technically. This gives us pi over 4. Sorry, I'm missing a squared here. Missing my squared. That gives me 3 times 36. Sorry. So it gives us 18 minus 54 plus 54, or 18 pi over 4, which gives us 9 pi over 2. Sorry, fix that one. Your x squared there. I put 3 over 2x. So the key here is if you're rotating around a horizontal axis, you should have everything with respect to x. Integrate with respect to x. Your functions should be y equals, or in terms of f of x, your bounds should be x values. If you're rotating through a vertical axis, you're going to be doing everything with respect to y. You're going to integrate with respect to y. Your bounds should be y values, and your functions should be in terms of y, or f of y. Okay. If you're rotating about an external axis, I suggest drawing a picture to try and help you figure out what your radiuses or radii should be. Okay. The last type of question you'll have here is if you have a solid, so you are not rotating, the solid is already there, you can draw a picture, 2D base of what that solid would look like, and then try and figure out what this thing is going to look like as a 3D object. The cross section's taken perpendicular. You'll be given a shape, circles, triangles, squares, whatever it is, and you need to figure out how to find the area of that shape. Your integral therefore adds all those areas together. Again, if you're doing perpendicular to the x-axis, you're with respect to x. Perpendicular to the y-axis, you'll be with respect to y. And that is all.